Okay, now that we really have this understanding of units we can use to talk about gene expression, and we understand how those units relate to things like normalization, we're ready to now move into the R and bioconductor environment with this really strong sort of foundation in sequencing, in the tools that we use to process that raw sequencing data, how those tools work and why we choose them, and what kinds of units we're going to be using to talk about gene expression moving forward. All right, so with that in mind, what you're looking at here, of course, is just a screenshot of RStudio. And I'm just putting this up because what we're going to do in this part of the lecture is actually start off on the right foot. So we're going to actually all begin by initiating an R project. And we do that by migrating up here to the top right corner of your RStudio window. We'll do this together in just a minute. And you click on that and you're going to get a drop-down menu and we're going to start a new project. And this is really important. There's maybe some temptation for some of you to just sort of skip over this because it's not essential, but it's really important that you do this for the course because it's going to allow us to pick up exactly where we left off with each class. So just by double clicking our R project and opening it, we'll pick up right where we left off. And if you don't sort of set up your R project now, there's a chance you might lose some of the work you're doing, or that your RStudio session will look very different than mine, or you'll need to spend some time at the beginning of each class trying to catch up. So what happens when we open an R project? And again, we're going to do all this together in just a minute. Well, a new R session is started, and your computer generates a few files in the working directory that you're in that, depending on how your computer is set up, those files could be hidden from you, and they're hidden because they start with this period. But it's basically all the personalized settings and information and history and data that you are working with when you were using RStudio for this particular analysis project. So you can see how that would be really advantageous. You have your profile, you have your data, you have history that includes things like previous commands you've used. You even get the current working directory just set by default to be the directory that you're working in when you open the R project. Any previously edited documents like scripts that were actually open when you close down RStudio are open when you reopen RStudio using that R project. And then other settings, many other settings, are restored to their previous state when you open the R project. So it's great, right? It's a great way to sort of pick up right where we left off. I just want to emphasize that it's not the same as an R script. So an RStudio project is really a workstation, a work environment that you're saving. And it's not a particular R script. An RStudio project can, in fact, and will, and even in our case in this class, have many R scripts associated with it. And so it's important that you understand that that's a distinction that we'll make. And at times I'll be talking about an R script, and other times I'll be telling you to open your RStudio project or your R project. So we're going to talk more about this in just a minute, but we use scripts in this class, and I've broken those scripts up into steps so that each step is accomplishing a certain task and is sort of, digestible. It's not too much to sort of bite off and chew. So we're going to actually open the step 1 script today. And that step 1 script, as I mentioned in the previous part of the lecture, is going to take us from our Callisto outputs forward to where we get that data into R and actually annotate it. And then we'll use additional steps later in the class, and we'll move through this step by step. And eventually taking us through an entire really sophisticated workflow for dealing with our own data or public data and plotting that data in many ways. All right, so the first thing that we want to do is actually, go get the first script that we're going to use. But before we do that, I want to just go ahead and get started by opening an R project. So I'm going to actually go to my computer now. And as usual, I'm sitting in a folder on Dropbox that has those Callisto outputs. Actually, that's what you have access to if you download these from the data page. So I'll just emphasize again, I don't care how you set this up on your computer with respect to where files and folders are. But I do ask, as I mentioned before, that you not move these abundance.tsv files out of their respective folders and that you not rename those TSV files. So What I want to do now is take the parent folder that has all these Callisto outputs in it. In my case, this is called Callisto_output. Remember, no names in no spaces in file names, no spaces in folder names. I want to take this folder and I'm going to drag and drop it on RStudio to open a new RStudio session that is looking in that folder. And remember, that's just a handy little trick that I showed you in a previous lecture. Great, it opens up. I see that it's sitting in the right directory. I can actually see those same folders. If I click on them, there's that abundance.tsv. And I see that I have my R console open. If you have your terminal window open as well, you can go ahead and close that. So again, this marks a real transition in the course. We had been using that terminal window for accessing Callisto and other command line programs like FastQC and MultiQC. We're done with that. We're not really revisiting that part of the course anymore. So you can close that terminal so that there's no confusion and that you're just looking at the console. Okay, I'm going to go up here as I indicated on the slide, click on the project tab and click new project. And I'm going to say I want, I get this pop-up window that says, well, do you want to create a new project in a new directory or in an existing directory or something we won't even talk about, in a version controlled project? I'm going to choose existing directory because I want to create this R project in the same folder where all these Callisto outputs are. So I'm going to click existing directory. By default, it's going to populate this directory field with the working directory that you're in. And I'm going to say create project. So that'll sort of open up a new RStudio session now, still looking in that same directory, but now up here it says, hey, this has now got a label, and that label is the R project is called the name of the parent folder it's in, and it tells you where it sits. Great. So just to demonstrate, I'm going to close this R project now. And if I look in that folder, now I can see, and you may not see this, by the way, a hidden R project user, an R history. I don't have a .r data because I haven't done anything yet in my RStudio project. I have my computer set to show hidden files and folders. Sometimes that's not a great idea. So if you don't see these, that's totally okay. But the important thing is I have a visible R project file here that I can now double click and pick up right where I left off in my analysis. Double clicking that R project, as I said, will take me right back to my previous state, including exactly the working directory I want. I don't have to mess around with that. And really any previous object I've created or scripts I've worked on will be here in my environment. Okay, so now that I have an R project up and running, I want to go ahead and get the first script from the website. So I'm going to go to the course website. And as I mentioned before, you can get the script from the lecture page for today, the step 1 script, or as I said, you can get them from the scripts page here. So I've downloaded that script. If you actually click on any of the script links, it'll tell you can download it and you can choose the folder you want to go to. I already downloaded it. It's sitting in that same folder right here, step 1. And again, only work with the step 1 for now. And so I'm just going to leave it there. I don't need to open it or double click it. It's actually here in my R environment. If I just scroll down, there is the step 1 tximport.r. So it's a R script because it ends in .r. I can just click it once and it opens. You see what happens there? My console moved down and now I have a text editor open. So not only did I have you download 1 or 2 text editors that are standalone text editors, but I had you also open a text file directly in RStudio. So why on earth then did I have you download these separate text editors? Because frankly, it's a pain to open RStudio just for the simple text editing function. So if all I want to do is edit like a shell script, like we did in the last lecture, I'll just do that in Sublime. But of course, if I'm working with an R script and I'm in RStudio, it's great that they have this built-in text editor. I don't have to have a separate application open. So my R script opens here. If I close that, it returns to like my full view being the console, and I could just click on it again and it'll open again. Okay, so this is an opportunity to just talk about sort of the anatomy of the R scripts that we'll be using in this class and sort of how these R scripts look in general. Anytime you open an R script, what they'll look like. So the first thing that I would ask you to do is to go, and we'll do this actually anytime we open a new step script for the class, is to go to Edit, Folding, Collapse All. I like to do this because I've organized all the scripts in the class in what are called code chunks, collapsible little bytes of code. And if we collapse all those, which is what I did when I went to Edit, Folding, Collapse All, it gives us this sort of 30,000 foot view of the script where we can see the bones of the script, right? Each of these code chunks is accomplishing something. It's got some goal. So by looking at it this way, these are sort of chapters in a book, right? We can look at each of these and know, all right, this is what we were trying to accomplish. For example, all of my scripts, all the step scripts will start with an introduction to the step 1 script. Then we'll load all the packages we need, and that's going to be the next thing that we'll talk about. And then there's some sort of step specific things that we'll do, like, you know, these are really at the heart of what we'll do in the next lecture. And then I conclude every script with a chunk entitled the essentials. And the essentials really strips out all the teaching stuff that I'm doing in these different code chunks, which we'll look at in more detail in a minute. Because as we walk through the actual code, I've got a lot of examples or different ways of showing things, mainly for teaching purposes. And you will at some point want to run this code, and you're not going to care as much about those didactic components. And so when you strip those away, what you're left with is the essentials, right? What's the minimal amount of code I would need to reproduce everything that step 1 did? The reason I put this together is not just for your use later, but also because at the end of this course, we will take the essentials chunk from each of the step scripts, and we'll use those to just quickly build a complete pipeline that's really reproducible and that you'll understand very well because you've worked through all the steps leading up to that point. All right. So we can go back to that Edit, Folding, Expand All now to open up all our code chunks. And you can see that really a code chunk is nothing special. It can have no code in it, like here. This is one chunk from here to here. And I know that's a chunk because it's got this foldable, collapsible icon arrow here that will fold everything from here down to the next one up, right? Now I'm just looking at this one. I could fold that one and keep going. So a code chunk can have anything in it, even just comments, which is what I have here. And the only thing that makes it a code chunk, the thing that lets RStudio know that this should be foldable, is the fact that I put more than 3 dashes after it. So as an example, if I take 1 dash away, watch this caret here disappear. You ready? It's gone. So that caret's gone. I can't fold this anymore. But if I add that dash back, you're going to see that arrow reappear here. All right? So more than 3 dashes after a line will fold or allow you to fold everything under that line up until there's another code chunk. So if I had no other code chunks here, if I took away all these dashes going down through here, it would fold the entire script up into one chunk. The other thing you may have noticed is the minute I deleted one of these, not only did this little foldable caret go away, but my title of my script turned purple and has an asterisk next to it. RStudio is telling me you've changed your script and you haven't saved it. So again, our scripts are separate from the R project. Both can be saved or not. And so we just want to be aware of that. All right, I told you step 1 is just an introduction, and that's just the way I've structured things. So I've got some learning objectives for the script, like this is supposed to serve as your gateway to R script. So you'll learn about the proper anatomy for an R script. You'll learn how to install packages and load libraries. And that's all we're going to do in this part of the lecture. We'll save these 2 bits for next week, which are to understand sort of the file types for RNA-seq data and get the data in, and then annotate our data. In other words, attach gene symbols, descriptions, really any kind of annotations to our human ensemble transcript IDs. And then I've just got a note here that, you know, the script is organized into chunks, what we've already talked about. So that introduction, that's it. You can fold that up. We're done with it. And the next chunk is loading packages. Now, one of the things I just want to highlight, since RStudio's built-in text editor is also code aware, it sort of colors things differently depending on whether they're functions from a package, like library as a function, or commands, or quotes. And then, of course, one of the styles here is comments. Any line that starts with a hash mark or number sign, pound sign, is treated as just human readable text that's ignored. And we take advantage of that to really richly annotate our scripts. And I sort of compare this to how we would use a written lab notebook for wet lab experiments. If we were to just paste in a Western blot image, like we would paste in code, and not annotate it with comments, not write in our lab notebook what we did, how we interpret it, and what the lanes of this Western blot that the gel was run with, what they represent, then it really lacks context and becomes really hard to interpret for anyone else, even for yourself down the road. So you're doing yourself a favor by adding lots of comments, and you're certainly doing everyone else a favor. So the comments can come before a line of code. Like this one is actually a comment. It just happens to be the header comment since I've added 4 dashes after it. And comments can come after a line of code, and comments can come in line, meaning I can put a comment at the end of a line of code, and anything after that pound sign will be commented out. Comments are also a useful way to turn off a piece of code, but without deleting it. So I could just put a pound sign if I don't need that library, but I know that that's easy to turn back on just by deleting that. So it's a good way to toggle on and off different parts of code, which is something that we'll use throughout the course as well. Okay, so the first thing that we want to do is load our packages. And this is a concept we're going to revisit each time we open a script. There'll be some software. Remember that initial discussion we had in a previous lecture about the R environment and statistics packages and graphing packages and modeling packages, and then that ecosystem of biologically oriented bioinformatics packages in Bioconductor, right? Well, when you downloaded R and you downloaded Bioconductor, you did not get the entirety of R and the entirety of Bioconductor. So there's a lot of software, a lot of R packages we'll be using throughout the course that you're going to need to download from a website, from a repository, and put into your library. All right. And your library is available here on the Packages tab. So here's the library of R packages. It's searchable, and you can always see what the package is, what it does, what version you're using, and you can always identify where that package is on its repository. So we want to go ahead and download our R packages, and it would be nice if we could just hit this install button and up pops a window, and we could type the R package we need and download it, install it. And so if we tried that, for example, with R HDF5, if we type R HDF, we don't get anything. R tries to autocomplete. It sees a bunch of stuff related to R, but the minute I type HDF, it's like I've got nothing. There's nothing I have for you to download. And so you might be inclined to just say, well, it's not available, I can't get it. But you have to realize that it's trying to install packages from one repository, which is the comprehensive R archive network, which is one of the biggest repositories for R packages. But CRAN doesn't have a lot of Bioconductor R packages available. So we need to broaden our search. We need to cast a wider net and look across many different repositories. So we're going to do that. It's nice to know we have this click and point install, and we're going to come back to that in just a minute. But it's also nice that we can use command line in the R console to kind of cast that wider net. So to do that, I'm going to type my first command in the R console, and that command is set repositories. Now, I just typed set, and I'm going to type repositories, or REP. And I see already one advantage of working in RStudio over just like working in the R console, which is RStudio will immediately recognize text as text aware, and it'll start to suggest or try to autocomplete what I'm typing. So it saw me type set rep and it says, hey, I see a set replace method function from the methods package. So the package name is always in the brackets. The function name is here in the first part. Set repositories from the utils package, and set breakpoint also from the utils package. And just mousing over any of these packages even tells me some information about, how to run that function. Now, I want to choose set repository, so I'm done typing at this point. I'm just going to mouse over and click on it. It auto completes and it leaves me with open and close parentheses. Now, just like we saw with Callisto, FastQC, MultiQC, once you want to run a function, you can augment it by supplying different arguments, -t for threads, right? So in R, it works a little bit differently. Those arguments fall inside of these parentheses, and they dictate how set repositories is actually going to run. And so if every function, or most functions, have default arguments that are set at their default settings. And so if you want to run a function, in this case, set repositories, and you just want to use the default settings, you don't have to type anything in the parentheses. The parentheses still need to be there, but you don't have to type anything in them. You're effectively saying, I just want the defaults. However, be aware that some functions, for example, a function to read in a file from your hard drive into the R environment, may have some default settings, but they're also going to have required arguments. It's going to need you to specify exactly which file you want to read in. It can't have a default setting for that. So, but in the case of set repositories, I can just use the defaults, and I'm just going to hit enter. And by the way, I could be anywhere in this word and hit enter. It doesn't really matter. When I do that, it says, please select the repositories you'd like to use for this session. And I can see that it's only got a plus sign next to CRAN. And that makes sense because that was the only one chosen when I opened the install window. And I can see that there are these bioconductor repositories that for sure I'm going to need, as well as extra stuff on CRAN and some other places. So just to cast the widest net possible, I'm going to choose all of these to be my default repositories that I look in when I click install. To do that, I just enter any or all of these numbers separated by a space, and I hit enter. So I'm going to do 1 space 2 space 3 4 5 6 7 8, and I'm going to hit enter. And nothing happens. Very typical of command line tools, right? Nothing. Sometimes no news is good news. But indeed, if I click on this install button again, I can see now I'm not just looking at CRAN, I'm looking at all of these repositories. So now if I type RHDF5, now I see I've got some options here. And I know from my script, that's the R package that I need. So I can choose that and I can click install. And it is now going to start installing that package. I actually already have RHDF5, but that's okay. You can always reinstall a package. It just basically updates it. I can see RStudio's thinking. It's got this little stop sign there. And it's actually currently running the install, and it's going to go through some stuff here and it's going to install. Now, again, everybody's got a different computer, different operating system, different sort of environment. So if you run into any issues installing any of these packages, you just need to let us know. We're sort of aware of some of the issues and have tried to mitigate them already by not giving you problematic packages to install. But you can see it finished. It went and found the package on Bioconductor in this case, and then downloaded it, and it's put it in the library. So if I hit the refresh button and I search for RHDF5, there it is. Now, important distinction here is that I have downloaded or installed the R package in my library, but like a book in a library, just because you have it on your shelf doesn't mean you're reading it. So in order to read it, in other words, the analogy being, in order to actually work with the R package in my script, I need to pull it off the shelf. And that's called loading an R package. And to do that, I use the library function, which goes into my library of packages and pulls that RHDF5 book off the shelf. And now it's open and ready to use. That software is running. It's ready to use in my R session. So in order to do that, I actually have to execute this line of code. Now, RStudio, as is often the case, gives you some options for how to do that. You could search for and find the package here and click it. And you can see that that actually did the same thing as I put in my script. But you're going to rarely do that, to be honest. You're going to rarely search for each package individually and select them. Instead, you're going to have, as I have here, a set of packages or software that you know you need to use, that need to be used to accomplish what you've done in the script, and you're going to load that stuff right up front. Some people load packages as they need them throughout the script. I like to have them up front because I can see right away what a particular script needs to operate. So, how do you run a line of code? You put your cursor anywhere on that line, beginning, middle of a function, middle of anything, in a comments section, doesn't matter, needs to be on that line, and then you hit the run button and it executes that line of code. And you'll see it actually executes that line of code and also prints off the comment. It didn't actually interpret it, but it prints it off. And so you could go through and execute line by line by line by line, loading each of the packages in your library. Each time you load a package, different packages will spit out different comments or notes or information, and that's all fine. And now searching for any of these other packages, like, for example, tidyverse, which is a topic of your homework for next week, now I can see that tidyverse has a check next to it because I actually loaded it from my library. So you could run line by line. You could highlight whole sections of code. You could highlight the entire script and hit run. You will run whatever your cursor is sitting on or whatever's highlighted. You could also highlight a single object, and we'll create objects in the next lecture for next week, but you could highlight a single object, and in that case, you're not running the whole line of code. You're just evaluating that object. You're asking if that object exists and sort of what it is. And again, we'll go over that more very soon. So that's how you download and install R packages and then load them from your library into your working environment. And that's going to be the first step in really being ready to do the things we're going to do next week. So I have a script here that's been modified, right? I changed a couple little things. So I'm going to just do save Apple S, and I see that asterisk goes away and I'm back to a white text label from my script. I should have also mentioned too that although you saw me go up here to run each line of code one line at a time, you're not going to see my cursor up here during the rest of the class, and that's because I use a keyboard shortcut to walk line by line through the code and execute each line. I do execute each line one line at a time so we can talk about what's happening, but I don't mouse up here and click. So I hit on a Mac, I hold down the Apple button, the command button, and while holding that down, I hit enter over and over and over again and just walk through line by line while talking to you. So you won't see me up here, but there's nothing wrong with going up there. All right, I've saved my script. It's open. I'm not going to close it. I could, but I'm just going to leave it open. And I'm going to go ahead and show you what happens now when I close out this RStudio project. I'm going to say, okay, so now this pops up and it says, hey, would you like to save your workspace image? And I want to say yes. I want to save that workspace image. That is the project, right? So if I say don't save, it's not going to save many of these things that I've done. So I'm going to say save, and it's saving that workspace image. It closes down, and I see this Callisto output R project still sitting there. If we pick back up and I have you double click that R project, it's going to launch RStudio looking in the right folder. And as soon as that RStudio session opens, I'm back to where I left off. I'm still in the R script. I mean, my cursor is probably even still in the same place. The same R packages are not loaded, so I have to reload R packages, but that's pretty trivial. Otherwise, it's the same, and that sort of memory, if you will, is really critical once we've created a bunch of objects, which we'll start doing in the next lecture. And so that's it. We now have a R project. We have our first R script open. We've talked about the anatomy of that script, and we're really ready next week to start reading data into R and talking about how we can work with that data for the rest of the course. And that's it.